In this video, we'll talk about how we can improve our programming. And we will not talk about Python-specific details, so what the best code is for a certain problem, but we'll take a more general approach. And of course, there are countless things that we can do to improve our skills, but here we will try to cover things that are most relevant for us as beginners. And so the first thing are notebooks, sometimes also referred to as Jupyter notebooks. And a notebook is what you can see right here. So that's a notebook file, and it has the file ending IPyNB. And so why are these notebooks so useful? Notebooks are made up of cells, so here we have one of the Markdown cells, here also a Markdown cell, and here we have a code cell. And whatever we define in one of these cells will be available throughout the notebook. So here we assign 2 to A, and then we can access this variable in another cell. So here we print A. To run or execute a cell, we can simply press Shift plus Enter. And the last object in a cell will be automatically printed. So here it wasn't even necessary to print A, we could have also just written A and it would have been printed. But this only holds for the last element. So here we assign 1 to B, then we have B and A, and only the A will be displayed. This cell structure allows us to break down our code into simpler pieces. And we can then test these simpler pieces or explore what they're doing. So imagine you have a very long script, and if you want to see what's going on, you have to include a lot of print statements, and that can get very messy. And so the cell structure allows us to see or explore what's going on in our code. With this cell structure, we can also easily rerun specific code pieces without the need of rerunning our whole script. So you can imagine that in this cell, we're doing some complicated calculation, which returns us a list of numbers and takes very long to compute. And if we then were to plot this list of numbers, it's possible that we miss an axis label or a title in our plot. And so in a script, we would have to run also the computation again. And if that is time consuming, then we're wasting a lot of time for a very small change. And so here in our notebook, it would be very easy to do the calculation in a separate cell and then rerun the plot in a different cell as many times as we want. Besides the code cells, we have the text or Markdown cells. And if we check out one of these Markdown cells, we see that we have a lot of options of making our text look nice. So we can, for example, add these headings or set our text to italic or bold. Besides these standard features, Markdown cells also provide much more. So for example, we can use LaTeX to create these equations, or we can display images using HTML, or we can also write code for demonstration purposes. So this is basically just an image and not actual code that we could use in a later code cell. We can also display tables, which can be really useful for displaying our data. So there are options to combine this with our code cells. And if we double click on this text cell, then we can see what's going on under the hood. So here we can use these double dollar signs to create a LaTeX equation, or here we're using HTML to display the image. And so in general, we can use these text or Markdown cells to help us with explaining or documenting our code. And this can be especially useful if you want to share some code with others. So maybe we describe the result of our data analysis, or we describe the details of what exactly our analysis consists of. And so if you want to make use of notebooks, you can either install Jupyter Lab or Jupyter Notebook. My recommendation would be Jupyter Lab since it has a nicer user interface. And to install Jupyter Lab, you simply open your terminal, then activate your Conda environment, and then you simply run pip install Jupyter Lab. And once it's installed, you can then run Jupyter Lab, now with a space, and that will open this window in your browser. And then you can click here to create a new notebook. And once it's done, you can simply press Ctrl+C and then terminate the notebook. As an alternative, you can also install the Jupyter extension in VS Code. Okay, next up is Googling, which is arguably one of the most important skills of programming. And this already connects to the third point, which is don't do it yourself. So if you're working on some project or some problem and you think that there's something that you have to implement by yourself, then there's a good chance that it already exists and someone made it available in the Python package index. So to give you some examples, let's say our goal is to generate prime numbers. And of course we could implement our own prime algorithm, but that is something that has definitely been done by other people. And so if we search for Python generate primes, and then click on the first result, that takes us to Stack Overflow. And the structure of Stack Overflow goes as follows. So first we have the question that is asked, then we have the different answers, and also sometimes comments on questions and also answers. And if there is a check mark on the answer, that means the answer solved the problem or answered the question that the person was asking. So that's always a good indication that it will also work for you. If it doesn't work out, we can just move on to the next answer. And it really pays off to not just copy and paste the code that is shown here, but to also quickly read through the answer. So here it says, for example, here is your code with a few fixes. But then below the code it says, for a much more efficient prime generation, see the Civ of Eratosthenes. And so then below it shows that implementation. And so we could copy and paste this piece of code here and we would be good to go. But we can also check if there's a implementation of this Csv in the Python package index. So we take this name here and then search for the Csv with py, standing for Python package index. And then here the first result takes us to the website of the Python package index. And from here we can almost install any Python package or library. And the installation is done by typing pip install and then the name of our package or library. So let's copy that. Then we go into our notebook. And normally we would do the pip install from the terminal, but we can also do it inside of the notebook here using this exclamation mark. Okay, and then let's check out how we can use this prime Csv. So here it lists the functions. For example, we have the function primes, which takes some number n, and then returns a list of prime numbers up to n. So let's try it out. We import from the prime Csv the function primes. And then we can call primes, maybe let's say with 10. And then we get all the prime numbers up to 10. Let's try 100, and that works really well. And so this is of course much simpler than doing it ourselves. And usually people also put a lot of thought into their packages. So their implementations will probably be more robust than our own. Okay, in our next example, we want to apply a Gaussian filter to an image. And so for that we search for Python Gaussian filter. And then we click on the first result. And that takes us to the documentation of the SciPy library. And here we see there's a function from this SciPy library called Gaussian Filter. So we have here all the arguments, and then we can scroll down for some examples. And it seems like that is what we're looking for. So here we have some image, and then we want to apply a Gaussian filter. So we copy all the code. We also install the library. And then let's try running that without any changes. And it will tell us Gaussian filter is not defined. So let's go back to the documentation. And apparently we missed some line, namely that one. So we didn't actually import the Gaussian filter. So let's take also that line. And now we applied a Gaussian filter to some image. But of course this is just some random image. So what if we want to apply the filter to our own image? Then we have to check how this code actually works. So we apply the Gaussian filter to this variable called ascent. And apparently this is the ascent of this staircase here depicted in the image. And so this ascent comes from the miscellaneous, which we imported from the SciPy library. And now the cool thing is we can easily check in the notebook what this ascent actually is. And we see it's a simple NumPy array. So that means for us, if we have some image, which we have in here, a cat image, we have to figure out how we can load that as a NumPy array. So we search for Python load image as NumPy array. Now we'll click not on the first result, but on the second one, since that is Stack Overflow, and it's usually a good first choice. So here we have the question, and then we check out the answers. So let's take that piece of code. We copy it into our notebook, and it will tell us that we need some library, namely the CV2, which stands for computer vision. So we go to the Python package index, we search for CV2, and let's check out the first results. This looks a bit odd since we don't see the 2 in here. So let's go back to the Stack Overflow post. And here we see a comment that says, for future reference, pip install OpenCV Python. So that refers to the requirement that we need to run this code. So we copy that, copy it in the notebook, and we're good to go. So now we specify our cat image, which is a JPEG. And then we can also have a look at our image. And now it says mode is an invalid keyword argument for imread. And maybe this has to do with different versions of our library. And for that we can again go to the Stack Overflow entry and check the comments. And indeed, here a comment says OpenCV seems to have dropped the mode argument. See my answer below for an updated method. So let's find the answer of this guy. That's not it. That also doesn't seem to be the answer, but it looks very convenient. So let's actually just take that piece of code and replace that. For that, matplotlib is required, which is installed in my current environment. So let's try and print the image. And there we have our image as an array. Great. Okay, and so all we do is we replace the ascent, which was the array form of this staircase image here. So we put our cat image in here into the Gaussian filter and also into the imshow, so that we first have the original image and then the image with the Gaussian filter applied. And if we now run our code, then we have our original cat and then the blurred cat. But right now our cat is all gray. So let's see what's responsible for that. And here we see plt.gray is called. So let's just remove that. But as we can see, our cat is still gray. So how do we fix that? Well, we Google. So we search for Python Gaussian Filter image only gray. We click on the first results, see the answers, and apparently that is working, but it's making use of some other package or library. So let's continue. And here we see grayscale blur and then color blur. So that's what we want. And here we see the argument multi-channel is set to true. That sounds good, since colored images have multiple channels. So we take that argument, pass it to our Gaussian filter function, and we get an error. Unexpected keyword argument. Well, let's go back to Stack Overflow, and we see that the Gaussian filter is not actually from the SciPy package, but from the skimage package. So we take that piece of code, replace all that, then we can check how we install the skimage. Maybe the pip skimage works. Here it says pip, so we click on that. And here it specifies a lot of stuff, but we're just interested in the correct name. So we take the scikit image and then install that. Okay, let's try again. Cannot import name Gaussian filter. So let's take that error message and ask Google. Again, we go to Stack Overflow. And here it recommends that we upgrade the scikit image library, but we just install it, so that's probably not the issue. And here we can also see here is a green tick mark. And here it recommends doing first from skimage import filter and then probably importing the Gaussian filter. So first thing, we try that. That is also not working. Let's take that to Google. We already checked out that post, so let's go to the next one. Here it again recommends the pip install -u scikit image, so maybe we try that. And it says the requirement is already satisfied, so that did not work. And things are getting really complicated, so let's do some backtracking and start with our original question again. So we search again, Python blur images. We click on the first result. And at this point, let's just copy that piece of code here. We replace our previous stuff. And here it requires the pillow library. So we check again, Python pillow with pip. That takes us to the Python package index, and we can copy the pip install from here. So we can install the library, and we can see it's already installed. So we can just put our cat image in here. And here we'll also save the blurred image. We don't actually need that. So let's run the code. And two images pop up, one being the original and one being the blurred image. And maybe you want the images to be shown not in external windows, but inside the Jupyter notebook. So for that, we could use matplotlib. So we type plt.imshow, then take our image, and then write plt.show. And then we can take that into a separate cell. So that's the original image. And if we replace that with the blur image, then we have the blurred version. Okay, now this took of course a lot of time, but it hopefully showcased how we can approach different problems. Okay, let's take that back to this cell here, and then we'll move on with reading CSV files. And you already saw one method of reading CSV files last week, but if we Google Python read CSV, and then also add the stack for Stack Overflow, then we'll see that there are multiple options. So this is the Python 3 version with the context manager that you might remember. But there's also a simpler version, which uses pandas. So let's just take all the code, copy it in here, and here we fill in our own CSV file, which is named countries. And we don't need all that here, also not the comments, just the read CSV. And if we run that, then this looks a bit messy because we're trying to print the data frame. If we remove the print, then Jupyter can apply its own way of displaying the data frame. And this looks much cleaner. And so the difference to using the context manager is that here we have to take care of the individual rows. And so it's not just a nice data structure that we can manipulate, but if we use pandas, then that gives us this data frame here. And without going into much detail, for example, we can access one of the columns. So let's say country. And then that gives us the country column of our data frame. If you're interested in how we can work with these data frames, then we could have a section on that in one of the final weeks. For now, let's move on to the last point, general advice. To improve our programming, it really helps, of course, to write our own code. And for that, it makes sense to work on some projects to have a goal in mind. And for you, that will happen at the end of the course, if you want to have a final grade. And besides writing code, what is equally, if not more important, is reading other people's code. Because that way you will get to know a lot of new syntax and how it's used appropriately. You'll have the chance to read other people's code by checking out the homework video, in which we'll go through how to solve some of the exercises.